In this video, you will learn about functions defined by equations. Let's illustrate with this following example. Tickets to the 5K race cost $25 each. The expense to organize the race is $500. Write a function that shows the relationship between the number of tickets sold and the profit. So we know that profit would be what you make. So what you make minus your costs, right? So what we make is based off the number of tickets. So we sell $25 for each ticket. So if we sell 0 tickets is $0. 1 ticket is 25 times 1. 2 tickets is 25 times 2, etc. So the money that we earn is going to be 25 times the number of tickets. So 25 times number of tickets. All right, and then we subtract the cost, which was 500. So the profit is $25 times the number of tickets minus $500. Now in math notation, we can use the letter P for profit and N for number of tickets. So our profit, or P, equals 25 times N, or number of tickets, minus 500. So this could be a way that I represent this example with math notation. Now we have some terms as well to be aware of. Domain is going to be what we can plug in for our variable. So in place of n, that's going to be our domain. So domain is the number of tickets. So domain could be any number of tickets. It could be 0 tickets, 1 ticket, 2 tickets, etc. Okay, so your domain would be each of these. Your range would be your p-value, or your set of possible profits. So your range could be anything. Once we plug a 0 in, we have 25 times 0 minus 500. So that'd be negative 500 is one possibility for my p-value. If we sell 1 ticket, it's 25 times 1 minus 500. That's negative 475. If we sell 2 tickets, it's going to be 25 times 2, so $50 minus 500. That gives me negative 450. And that would continue for however number of tickets that we sell. All right, so this is your range, all the possible profits that I could have earned. Now looking back here at this equation I created, there are different ways in which I can represent this equation. I have, first of all, what is called arrow notation. So looking at the same equation, I could write it like this, where I have P colon N, arrow, and then 25N minus 500. What this means in English is the function P that assigns 25N minus 500 to the variable N. Okay, this is one way to write this. And this is actually not used as often as the following. The following is function notation. And we can write this in function notation as P parentheses N equals 25N minus 500. So we simply put a parentheses and N right here. And we put an N here to show that our function is in relation to N. So the profit is in relation to N. Whatever N is, that's going to give me back out my profit. So in English, we would say this as P of N equals, and that should be 25N minus 500. So 25N minus 500. Now let's spend a few more moments and get more familiar with both arrow notation and function notation. So here we are to list the range of h colon x mapped to x squared minus 2x plus 3 if the domain D equals negative 2, negative 1, 0, 1, and 2. So this is an arrow notation, it might be easier to write this in function notation. So this can be written in function notation as h of x equals an x squared minus 2x plus 3. Okay, so this is function notation. Above is arrow notation. So what I want to do is I want to use this domain, -2, -1, 0, 1, and 2. And we're going to plug in these numbers in place of x and figure out what I get back out. Because the domain, by definition, are x values. And range, by definition, would be your y values, or what you get back out. Okay, so in this case, instead of y is h, but same concept. And by the way, this function notation, I can actually think of this as y equals x squared minus 2x plus 3. This is all really the same thing. So function notation is really another way of writing y equals something. So if it's y equals something, we know how to solve for y by plugging in numbers for x. And we're doing the same thing here. So in this column, we have our different x values that we're going to plug in. So -2, -1, 0, 1, and 2. And what I'm doing is I'm plugging these in for x squared minus 2x plus 3. So in place of x, I put in these different numbers. So for -2, we're going to have -2 squared minus 2 times -2 plus 3. All right, so -2 squared is 4. So we have 4, and then -2 times -2 is a plus 4. So 4 plus 4 is 8. 8 plus 3 gives me 11. Then I plug in -1 in for x. I have -1 squared minus 2 times -1 plus 3. -1 squared is positive 1. 1, and then -2 times -1 is a positive 2. So 1 plus 2 is 3. 3 plus 3 is 6. Then we can plug a 0 in. We have 0 squared minus 2 times 0 plus 3. So 0 minus 0 plus 3, that equals 3. Next we can plug a 1 in. So we have 1 squared minus 2 times 1 plus 3. 1 squared is 1. 2 times 1 is 2. So 1 minus 2 is -1. The -1 plus 3 is going to be 2. And then lastly, we plug a 2 in. So we have 2 squared minus 2 times 2 plus 3. 2 squared is 4. 2 times 2 is 4. So 4 minus 4 is 0. 0 plus 3 would give me 3. So right here, the 11, 6, 3, 2, and 3, that is my range. Those are the y values, or the values that I get back out when I plugged in these different things for x. So we can write the range out like this, but this is not usually too helpful because how do we know which y value went with which x value? So what I can do is to show that a particular domain value is paired with a particular range value, we can use function notation, or we can write as an ordered pair. So using function notation, we would say for this first one right here that h of -2 equals 11. Okay, remember looking right here at h of x equals x squared minus 2x plus 3. We said x was -2, right? We plugged -2 in for x. We plugged in here and here. So plugging -2 in for x, we now have h of -2. And when I did that, when I plugged -2 in, 11 was my answer. Okay, looking at the h of x function again, if I plug -1 in, we now have h of -1 equals something. And we found that when we plugged -1 in, we got a 6 back out. So I can write this in function notation as h of -1 equals 6. Same thing now with the 0. We plug a 0 in for x. We now have h of 0 equals 3, because when we plugged a 0 in, we got 3 back out. For the next one, we plugged a 1 in for x. So now we have h of 1. And when we plugged a 1 in, we got 2 back out. So h of 1 would equal 2. And then lastly, with the 2, we plugged a 2 in for x. So now we have h of 2 equals, and that was equal to 3 when we plug the 2 in. So h of 2 would equal 3. So we have this written in function notation to show that the negative 2 goes with 11, negative 1 with 6, and etc. We could also, in addition, write this as an ordered pair. So all of this is just different ways to write the same thing. Okay? If we wanted to, we could write this as negative 2, 11. Because when we plug the negative 2 in for x, we got back out 11. So negative 2 is my x value, 11 is my y value. Here we have negative 1 comma 6, 0 comma 3, 1 comma 2, and then 2 comma 3. Because for each of these, our x values are listed here. Our range, or our y values, would be this on the right side. So like I said, all these are different ways of writing the exact same thing. Let's work a little more with this different notation. Here we have arrow notation. If we wanted to, we could write this in function notation. So this would be f of x equals 2x squared plus 3x. So here we are told to find f of 0, f of 2, f of negative 4, and f of 5. So notice how in place of x, I put in these different numbers like 0 or 2 or negative 4 or 5. That's what I'm doing to figure out what each of these are. I'm plugging these numbers in for x. So plug it in over here for x as well. So here's a little table with all this information. So f of 0 is right here in this first row, and in this column we see our function. So f of 0 just means I plug a 0 in for x. So I have f of 0 equals 2 times 0 squared plus 3 times 0. So 2 times 0 is 0, plus 3 times 0 is 0. So 0 plus 0 equals 0. So f of 0 would equal 0. For f of 2, I plug a 2 in for x, so now I have 2 times 2 squared plus 3 times 2. 2 squared is 4, 4 times 2 is 8, 8 plus 6 equals 14. So all of that equals 14. F of negative 4, I plug a negative 4 in for x, so now I have 2 times negative 4 squared plus 3 times negative 4. Well, negative 4 squared is a positive 16, times 2 is 32, and then here 3 times negative 4 is negative 12, so I have 32 plus negative 12, which gives me 20. So f of negative 4 is 20. And then lastly, with f of 5, we plug a 5 in for x. Now we have 2 times 5 squared plus 3 times 5. 5 squared is 25. 25 times 2 is 50. 50 plus 15 gives me 65. So f of 5 would equal 65. And so we have our different solutions, and this is one way we can write our answer. And if we really wanted to, we could write this in an ordered pair as well, but there's not really need to unless you are being asked for the ordered pair. And that concludes our lesson for today. We will see you next time.